So today I'm going to tell you basically how the Jira team, a team of mostly server-side developers, learned to get better at implementing large and complex features entirely on the client side in JavaScript. So this is the Jira team. So we have about 50 developers now in Sydney. We also have a number of people in Poland and a couple in Amsterdam and San Francisco, but the majority of the team is still in Sydney. Now, what's interesting about this team is that of these 50 developers, only 6 are in fact front-end developers. And of these 6, only 3 are in fact JavaScript developers, and the remaining 3 are our HTML and CSS experts that do all our markup. Now, this presented a fairly big problem for us because we realized last year that implementing features on the client side offers a lot of benefits to our users. So with client-side features, you can achieve a much better user experience. So if we're taking Line Edit as an example, within Line Edit, we can let our users, for example, edit one field and then jump straight to editing another field without making them wait for a response from the server. Also, they can edit without having to jump into an annoying dialogue or jumping to another edit page, which really just distracts them from the editing experience. And we can do smart little things like update the view issue page without reloading the entire page all the time. And so really this gives you a user experience that feels a lot faster to your users. But aside from this, you can actually get some real performance benefits from having a full client-side user interface, because you no longer have to transfer large amounts of HTML markup from your server to the client over a slow network, but instead you can just transfer little bits of JSON data that you need to then render this UI on the client side. And also your browser doesn't have to spend a lot of time often parsing megabytes of JavaScript whenever the page loads. And so you can get a UI that feels a lot faster and is in fact a lot faster. And by implementing a feature entirely on the client side, you're really killing 2 birds with 1 stone, because it forces you to really implement a full REST API. And so when we implemented in Line Edit, we were really forced to make some additions to our REST API and to add some new REST APIs to support editing of individual fields from the client side. And this is really something that benefits everyone in this room. And if in fact more plugin developers switch to this way of developing features, Jira and all our products will end up with a much more complete remote API that really benefits the whole developer ecosystem. But there's a big problem with this approach, and that's that JavaScript development is quite difficult. So we've been doing this for quite a while, and we've only really developed mostly small UI controls, autocompletes, drop-downs, and things like that. And even with these smaller features, our track record hasn't been all that great. So JavaScript development has always been a big source of bugs for us, a big source for regressions. And really, the code that we've ended up with has always been kind of suboptimal. So the JavaScript wasn't very maintainable, and it was just a bit of a mess, really. Now, the simple solution to this problem might be to just hire more JavaScript developers, but this really fails for 2 reasons. One is that it's really hard to hire good JavaScript developers. It's even harder to hire than it is to hire good server-side developers. And the second reason why this fails is that even if you hire good JavaScript developers, they're generally not very good at architecting large and complex pieces of software on the client side, because that's not what we've been asking them to do traditionally. Traditionally, we've asked our JavaScript developers to implement little UI controls, fancy drop-downs and things like that, but I don't have much experience in rewriting, say, an entire issue navigator client-side or rendering entire view issue page client-side and all the inline edit controls. And so really, this is what this talk today is all about. We needed to find a way of allowing our backend developers to become more effective at writing features completely on the client side, because they had a lot of knowledge about how to engineer features on the client side. And so in my talk today, I'm going to show you the 3-step process that we went through in the inline edit team to get better at implementing features on the client side. And then for the rest of this talk, I'm going to show you all the benefits that we realized through following this approach on the inline edit team. So let's jump straight into this 3-step process that we followed. So So the first step was really to do a bit of research. So about this time last year, we realized that we needed to get better at client-side development. And we did a bit of research, and this book is by far the best resource that we could find. So this is JavaScript Applications by Alex McCall. And this book doesn't talk about JavaScript the language or jQuery at all, but instead it introduces the notion that you can apply design patterns like MVC just as well on the client side as we have been doing for ages on the server side. And it shows you a number of client-side frameworks like Backbone.js, Spine.js, and JavaScript MVC, and shows you how you can build little sample applications with these frameworks. And so this was really a bit of an eye-opener for us. And we made this required reading for everyone on the inline edit team. But we didn't just want to trust this book blindly. And so the next step for us really was to do a spike. And so in the usual Christmas dead period, so when everyone goes on leave last year in December, we took 6 developers and we gave them 2 weeks' time to figure out answers to some of the questions we needed to answer before we started working on inline edit. So some of the questions like, should we use a JavaScript framework? And if we use one, which one should we use? And how do we use this framework in the most effective manner? And so during this spike, we essentially worked in really short iterations. We had daily iterations where we would pair developers up and set them fairly small goals. So for example, we would take 2 of our JavaScript developers and set them the challenge to implement their own JavaScript framework that would allow our backend developers to be more effective at writing code on the client side. The reason we did this is because our JavaScript developers had been the most critical of frameworks like Backbone in the past because they found them to be very restrictive. And what was interesting about this was that they came back within a day and told us that there's no point in implementing our own framework because we would more or less implement the same functionality that one of these client-side frameworks already offers anyway. And so our focus shifted very quickly to figuring out which framework we should use. And so we then tried, over the next couple of days, we tried Backbone.js, Spine.js, and JavaScript MVC. And of those 3, Backbone.js won out for us because it was the most flexible and it was very easy to extend and easy to learn. Spine.js was still a bit immature at the time, and JavaScript MVC felt more heavyweight compared to Backbone.js. And so then for the rest of this spike, we really focused on learning Backbone.js and figuring out best practices on how we need to use Backbone.js in the best way for inline edit. And we really did this by building a small library application. And so the final step of this process then really was to pick a framework. Now, I'm not saying that all of you pick Backbone.js. There's now a large number of really good client-side frameworks available that help you write applications on the client side. So I really encourage you to run a spike yourself and play with a number of these different frameworks and pick the one that works best for your team. And that was really it. So this was the 3 steps that we went through, and this put us on a really good path for developing inline edit entirely on the client side. So now I'm going to show you some of the benefits that we realized through developing in this manner for inline edit. So the first thing you get from picking a framework like Backbone.js is a documented approach. So in Backbone's case, you get an MVC pattern. So you get Backbone models, which represent your data, and are also responsible for synchronizing that data with the server, so firing all the AJAX calls to your REST API and so on. You get Backbone views, which in a traditional MVC framework is really what I think is the controller. So Backbone views handle user actions, click events, and so on, and interact and update models. And you get templating. So Backbone doesn't provide a templating framework for you, but it makes it easy to plug in any kind of JavaScript templating framework to then render the DOM elements and to view for your UI. Plus, it provides a lot of other nice utilities to deal with collections of models, for example, and it provides a lot of nice utility methods to search a collection of models, to filter collections of models, and so on. But the main advantage here is really that this improves our long-term maintainability of our code. By picking a framework like Backbone.js, we can simply take a new developer that joins our team, point them at the Backbone documentation and some Backbone example code, and they're already 80% of the way there to being an effective developer on inline edit. And this was really important for us because this inline edit code has to be around for a long time, and so it has to be easy to bring new developers onto this team. The other thing that picking a framework like Backbone.js does for you is that it allows you to engineer your JavaScript code a lot more. I think we've all been there and we've seen sort of your typical JavaScript application, which is like one big monolithic 1,000-line JavaScript file with a lot of bad code smells and global functions and global variables and things like that. But with Backbone, you're forced to really break a large complex problem down into small manageable classes and components with very limited responsibility. So here's a practical example of how this actually helps. So this is Nappy, the Notes API. So this is a small extension that we wrote for support.atlassian.com. So this allows our support engineers to write customer notes about customers to deal with in a support case. And so they can write notes like this, for example, where one support engineer might be telling other support engineers that this customer is running a lot of applications on the same server and it's caused performance problems in the past. Bear this in mind when you're helping out this customer. And so the functionality is fairly simple here. We can add notes, edit them, remove them, and display them. Now this had been implemented over time by a number of support engineers as kind of like a typical JavaScript application. One big monolithic JavaScript file, 691 lines of code. And this was pretty bad. It had global functions, it had lots of HTML concatenated as strings with data, and global variables, all the bad kind of code smells that we should avoid in JavaScript. So we recently went through rewriting this with Backbone. And this is what we got as a result. So immediately, it becomes a lot easier for a new developer in this project to really understand what's going on. So it now becomes very easy for a new developer to really understand how this bit of functionality functions. So for example, we have a node model.js file which represents your data and is responsible for synchronizing customer nodes with the server. We have a node collection which represents a number of these node models for a particular issue. We have a templates.so file which is used to render these nodes on the client side. And then we have a number of Backbone views which are really responsible for all the different actions you can take. So you can edit nodes, you can add nodes, and so on. And what's also nice about this is that all these individual components are shorter than 100 lines of code. So they have very small responsibilities with very cleanly defined public APIs, which makes it a lot easier to maintain in the long run once again. Plus, overall, we ended up saving about 70 lines of code as well, just because Backbone.js provides a number of nice little utilities to help you out with some of the things that we have to do in this bit of code. So this ability to break things down to small components means you can you end up with code that's maintainable in the long run. But really, we also wanted code that was maintainable in the short term. And for us, that meant we needed to be able to refactor effectively on the client side. Now, that's something that is something that we've been really scared of in the past, because when you're refactoring in JavaScript, you don't have compile time safety. So if you make a change somewhere in your JavaScript, you don't know what it's going to break, and you're only going to find out at runtime when your users are actually using your bit of software. Now, Backbone.js is not going to give you compile time safety, but it makes the risk and the problem of refactoring on the client side a lot smaller. So this is an example from how this helps from inline edit. So this is our first architecture of that we came up with for inline edit. So you can see here we had a number of models and controllers that were responsible for rendering a view issue page. And then very tightly coupled to this, we had an issue field collection and issue field models and field views, which are responsible for rendering the inline edit controls for a view issue page. And we had two main problems with this approach. One was that editing was much too tightly coupled to viewing an issue. And the other problem was that we had two places in this model that was making REST calls to the server and asking for data from the server. And this meant that we ended up with code like this. So we basically had an issue panel model, which is responsible for rendering the view issue panels, so description and attachment blocks. And this would fire a request to the server. And when that request came back, it would trigger a panels fetched event. And this would then call a refresh fields method, which fire another request to the server to get the inline edit controls. And this would then trigger a fields fetched event, which would then trigger, okay, we both have the panels and fields fetched now, and you can do something else, like render the whole viewsheet page now. And if you've ever had to debug a nested events chain like this in JavaScript that depends on AJAX calls that can come back in different order and can have delays, it's an absolute nightmare. And this was a huge source of bugs and problems for us. So we had to come up with a way to fix this. And so the new design that we came up with on the whiteboard is we separated all the editing controls and pulled them away from viewing an issue. And we decoupled them completely by introducing a new object, which was the issue event bus. And so both sides of this model, so viewing an issue and editing an issue, would simply trigger events on this event bus and listen for events on this event bus. And that allowed us to then introduce two global objects who are responsible for firing requests to and from the server and batching up potentially multiple calls from the server, and then pass completely constructed JSON objects to our backbone models. And this meant we could get rid of this events chain, which really solved a lot of these problems that we were seeing. Now, to implement this refactoring took us 1 day with one JavaScript developer. And we in fact ended up solving more bugs than we introduced during this refactoring. And that's mainly because with backbone components and models, you end up with these really small JavaScript files with clean APIs that are very easy to recompose in different ways. Now, templating is another benefit that I hinted at briefly before. So I mentioned Backbone makes it possible to plug in a templating framework. So this is an example of what not to do. So here we have a JavaScript function which has a bit of HTML as strings concatenated together with data. And we have to do all the nasty things like escape single quotes and double quotes. I mean, it should be HTML escaping our data, which this code isn't doing, by the way. So we've probably introduced some XSS security holes as well. Just out of curiosity, how many here in this room have this kind of code in their JavaScript at the moment? There's a couple of people. So there's a much better way to do this now with Google Closure templates. So just like a templating framework on the server side, you can now write HTML markup again and HTML code, and you can insert your data using some simple little escape characters. And you also get nice little logic constructs like if statements and for loops to deal with more complicated bits of data. And the best thing about this is that this gets compiled to JavaScript, which is then fully batchable and cacheable on the client side. So you don't get any performance penalties for using this approach either. Now, testing is probably one of the biggest benefits that we realized through developing inline edit on the client side. Now, this may come as a bit of a surprise because in the past we've been advocating to use Selenium and WebDriver to test any bit of JavaScript functionality. And anyone who's ever had to write a Selenium or WebDriver test knows that it's really not that much fun. So Selenium tests are quite difficult to write so that they're reliable, and we often had a lot of timing issues and flakiness. So I'm just going to show a few Bamboo statistics here. So this is a plan that runs all the WebDriver and Selenium tests for the Jira code base. And so over time, we've had about 1,000 builds execute this test suite. And what's immediately apparent here is that of these 1,000 builds, only 41% were actually successful. So that means if I'm committing to the Jira code base, more than half the time, I'm going to get a negative result back from this test suite. And that means the entire test suite uses a lot of value to me as a developer immediately. And in fact, that's what we started seeing on the Jira team. People started to really ignore the results of these Selenium tests, and we ended up with regressions that would stay there for 2 or 3 weeks because no developer would look at these negative build results for 2 or 3 weeks, simply because there were so many negative results due to timing issues and just Selenium flakiness. The other problem with the Selenium builds that we've had with Jira is that to run 917 tests takes 33 minutes on average. But that's with 29 parallel build agents. And so there's a real cost here in maintaining and running all that hardware. And somebody has to go and maintain all this Bamboo setup as well. And so clearly, we needed a better way to test inline edit for this to be successful. And so we had a closer look at QUnit for testing functionality on the client side. Now, we'll look at what you can test with QUnit in more detail in a second, but first I want to show you some of the statistics. So this is a build plan from inline edit. And so we had a very similar number of builds, almost over 1,000 builds as well. And you can see straight away that 90% of these builds came back successful. And so that means if you checked into inline edit, you really knew, and you got back a negative build result, you really knew that something broke for real. There was no flaky build failures. And the other big advantage here is that in order to run 785 tests, Bamboo only takes 70 seconds. And that's on one single build agent. Now you might go, that's pretty good. If I commit, if I get a result back within 1.5 minutes, that's pretty awesome. But Bamboo actually has to do a lot of things, because it has to start up a container, it has to start up Jira, it has to start up the browser, navigate to the right URL. If you're developing and you have all these things already running on your local machine, you can in fact run all of these 785 tests in 4 seconds. Now that's a huge advantage to any development team, because that means all your developers in your team can run all the tests before committing their code, and you prevent a lot of these problems where one guy checks in some code that breaks 20 tests, and the 4 other people on your team then check out that broken build, and they all get affected by this, and so your entire team is slowed down by this until you figured out who actually introduced the failure. So that's all nice and good, but you might be going at this stage, well, that's all great, but these are unit tests, right? But really what I want to be testing is functionality. So I want to write functional tests like I would with Selenium. So I want to make sure that some text shows up in the right spot in the UI, or clicking a button causes some action to happen. Well, it turns out you can actually do a lot of that with these QUnit tests as well. So here's an example of a QUnit test, and I'm going to run through this line by line. So this particular test essentially tests that given a bit of data that we would normally get from the server, our backbone models and views can render an issue panel for the view issue page. So think like the attachments block. So the first thing we need to get here is a little bit of JSON data. So here we're just defining a mock web panel, which is something you'd normally get from the REST resource, but here we can just copy the JSON from the REST resource and hard code it in this test. And then next, we need to do a little bit of setup. So this is just like a setup method in a unit test that you'd write in Java code on the server. So the first thing we want to set up here is we want to create a little mock div, which is where our view will render this panel into. And then we create a backbone issue panel model using the mock data we got from them that we just defined in this variable up here. And then we define our backbone issue panel view using this mock DOM element and the model that we just created. And now we're really ready to run our test. So we've done all the setup. So this particular test tests that given this data, this panel will render without a header, essentially. So the first thing we do here is we call panelView.render, which returns us a jQuery wrapped DOM element that contains the view that we just rendered. And the cool thing about this is that in your test now, you can use the power of jQuery selectors to run your assertions. So for example, we can test that this particular panel doesn't contain a header. And we can test that this is the add comment panel. And we can check that it's got a footer comment button at the bottom. And you can actually take this further and test that certain bits of text are shown. You can simulate click events on buttons and make sure that the UI updates after clicking a button. And also you can check that the backbone model got updated correctly. And so really, with inline edit, we were able to test about 70 to 80% of the functionality using these kinds of QUnit tests that are really fast and easy to write and execute a lot faster, more reliably than Selenium tests. You're still going to need some baseline Selenium tests to ensure that your client-side code is communicating correctly with your REST API on the server. And you will need Selenium tests to click back and forward buttons in the browser to make sure push state is working correctly for your application. But the majority of your functionality can be tested with these QUnit tests. So this really brings me to the last and probably by far the biggest benefit that we saw through developing in Untitled on the client side, and this is development speed. So instead of talking about this, I'm going to show you a video of what I mean. So here we have one plugin that's implemented in two ways. So on the left-hand side, we have this plugin that's implemented as a server-side plugin, so there's some Java code. On the right-hand side, we have exactly the same plugin, but it's all implemented in JavaScript. And this plugin simply adds a nice little view issue web panel, Atlas Camp 2012 with a welcome message. And so when I play this video now, we're going to have a look at how long it takes from making a change in your IDE to actually seeing that change in the browser. So let's run this video. So we're going to jump to the IDE here in both windows. And we're typing exactly the same change on both sides. We're changing the welcome message. Now on the right-hand side, I can simply hit save for my JavaScript file. And because I have live reload enabled, the browser's already reloaded when I come back to the browser. And it took only 11 seconds to make this change. On the left, I had to change some Java code. I had to then recompile my plugin, reload this plugin, and reload the browser. And this took over 20 seconds. And so we're looking at a 10-second improvement here for from making a change to seeing the effects of that change in the browser. Now, when I'm developing, I do this kind of thing every couple of minutes. And so on a weekly basis, you can save over an hour and a half by implementing your functionality in a client-side plugin. And so for inline edit, where we had about 6 to 7 developers working on this, we were able to save over 10 hours a week by following this approach. And in fact, in the real world, this saving will probably be even bigger because as your server-side plugin grows and you have to compile more and more Java code, reloading this plugin takes longer and longer. Versus reloading lots of JavaScript files will stay more or less constant because browsers are just so fast at interpreting JavaScript these days. And so this really brings me to the conclusion of this talk. So as we saw, there's now a number of really good client-side JavaScript development frameworks that really help server-side developers develop code effectively on the client side. And browsers have really caught up in recent years as well, and you now get all the fancy debugging and performance profiling that we're used to from the server side. Plus, if you couple this with QUnit, you can also do some really fast and effective testing on the client side of your code. And what we found with inline edit is that even our, I guess, oldest server-side developers, or people who really hated JavaScript development previously, started enjoying this new approach of developing. And in fact, now they love developing in this way much more than developing on the server side, simply because you can spend so much more time focusing on the features for your users, and you don't spend your time debugging a flaky Selenium test or waiting for your plugin to reload. And so I highly encourage you that the next time you have to implement some large and complex bit of UI functionality in one of your plugins, really give this approach a go and develop it entirely on the client side. Thank you.